The sad truth about uric acid, elevated uric acid, is that it's not just one thing. And it really takes not a highly technical eye or a lot of what are all the variables about, but what you're being told isn't truthful in my view, that uric acid is primarily and nearly always associated with insulin resistance. This is what I thought I believed for the previous couple decades, And there wasn't a lot of people that had semi out of range, elevated, uricemia. But it's changed over time. And so the population has changed. What is driving that? Yes, we can say it's insulin resistance because we can say, yeah, most of the population is obese, and then certainly the majority of them are type 2 diabetic. So yes, that makes sense, but that's not the only thing. People have come to me, and you can see some of the comments in some of these presentations I've done. If you followed the sequence of presentations I've done on uric acid, it's like, wait a minute, I started a carnivore diet and I'm feeling great in many ways, but I had my first episode of gout and I've never had that before. The sad thing about discussing uric acid is that you're not being told the truth. You're being given a very simplified version of something that is growing to be rather catastrophic. Globally, I will prove to you that this rates have easily quadrupled over the last 40 to 70 years, if not the last 10. Hold your breath. Time to have an honest conversation that goes beyond the simple explanations of the last 1,000 years or so, or even of the last 50 to 100. It's not just purines, it's not just alcohol, it's not just high fructose corn syrup. There's plenty of people that have none of those as major factors in their diet and lifestyle, and they get gout. What is going on? You always can say genetic predisposition, and that's a factor for everybody and everything. So we're not going there on this particular video, maybe in the future. Let's dig in. So your uric acid is increasing. Is it? Do you know? What's happening is gout's increasing, fatty liver is increasing, cognitive decline is increasing, cardiometabolic issues are increasing because uric acid is getting too high. So what is the range we're looking at? Let me give you the cutting edge understanding of what is the optimal range to get in. More than likely, you've been told your uric acid is high, hyperuricemia, and your gout is due to elevated uric acid because of purines, or you're consuming high fructose corn syrup products, the donuts, the sodas, the energy drinks, pretty much any processed foods, even the coleslaw, by the way. Or you're drinking too much alcohol or too frequently. What we are told to believe is that it's all about the high fructose corn syrup, the sodas. It's all about the alcohol. Beer is clearly the most aggravating. And then purines, which are, people reduce that list down to, and I've done a whole nother video of what are purines, and it's up here. That's a contributing factor, but very few people fit into that particular category. But what they all have in common in terms of this explanation is that they each one of them drive up purines. Here you're eating purines, right? You're eating it. It's exogenous purines that came through foods. Organ meats, cured meats, some seafoods, the mackerel, sardines, and so on. The beer and the sodas, they are making you make your own purines. So this story is all about purines. The question is, how much are you making for yourself and how much you're eating? I can almost guarantee that anybody who's watching this, probably 99% are making their own purines and wondering, what am I eating? What's happening? We're going to go into that, okay? So having a higher serum uric acid could be a risk for hypertension, high blood pressure, dyslipidemia, elevated cholesterol, chronic kidney disease, and diabetes, not to mention declining cognitive health, leading to dementia and Alzheimer's disease, all-time highs. The optimal serum uric acid range for developing cardiometabolic diseases could be less than 5 milligrams per deciliter, just 5 for men, and 2 to 4 for women. This comes from a number of studies in the last few years. When I say last few years, literally I mean the last 3 years. This is from a Japanese study, and I think it was the most articulate and the most refined, and certainly the easiest to follow. So the take-home point is routine screening of serum uric acid is useful. So if you're just going to show up to the doctor, make sure he is taking your uric acid year after year after year. I'm going to argue that you should be taking your own initiative to find out what this is for you in your life. because routine screening of serum uric acid is useful as a predictor for cardiometabolic diseases. And that's from a study in 2020. The rate of being free of various cardiometabolic conditions according to serum urate levels over 5 years. And there's the reference for you to be able to look that up. Hope you do. Here's more from that study. This is pretty interesting. So here what they did is they simply took the prevalence. They had the people march in, what's your uric acid? What conditions do you have? So what they found is those that had hypertension had and this is the whole scale, for everybody who marched in who did have high blood pressure, they found that of those who had a uric acid reading of 2, were only 10% of all the people of the population in general, representative of the population in general of Japan. And they did thousands of people, and they really worked it down to read all about it. It was done a really good study. So only just about 10% had 2. This is an interesting graph. 2 to 3 of all the people that had high blood pressure, 30% had 2 to 3. Then it dropped down, and then it started to rise again. So that's pretty interesting. We'll get into that in a second, why that happened. Over here for diabetes, for everybody who marched in, who had type 2 diabetes, marched in and says, what's your uric acid? And they put all this data in. They found that those who had 2 or less, which is pretty much hypo uric acid, 10%. So 10% of all the people who had 2 or less had, of all the diabetics, only this represented 10% of them. Of those who had greater than 2 and less than 3, 14 of them had diabetes, 14%. And so you can see it rises and then it falls. And this is really pretty interesting. In part, it has to do with the kidneys wanting to hold on to the glucose and hold on to the uric acid and get rid of the glucose. So it's a little bit of a confounding factor. So dyslipidemia, in other words, elevated total cholesterol is what they measure here. Serum uric acid is it's basically lower is better. So the lower the uric acid, the lower the total cholesterol was. So they had a correlation there. And so the higher the uric acid, 9, was 80% of the people who had 9 or more had elevated cholesterol. 40% of those who had less than 2 for uric acid, had elevated cholesterol. Then you can go on to chronic kidney disease, and there's another pattern. So they went through a lot of numbers, and they're saying in all 4 of these are considered cardiometabolic conditions, 1, 2, 3, 4, is that they figured for all of this, the lowest prevalence of blood pressure, non-dyslipidemia, and no kidney disease was between 2 and 4 for women. Remember that, 2 and 4 for women. And for men, pretty much the same thing. It was between 2 and 6, but you'll see that it should be 5 when I give you a little more information. So now what they did is 5 years later, they had the people walk in again. And this time the question they asked was, how many people have not had hypertension for 5 years? How many people have not had diabetes for the previous 5 years? How many people have not had, boom. So what they find is, again, the lowest uric acid reading was correlated with the high no hypertension. Pretty straightforward, right? And the blue is men and the red is women. Pretty tight correlation. And higher is better with a slight variation. Lower the uric acid is better, and the higher the uric acid is worse. It's pretty much across the board. With diabetes, it's a smaller and smaller and smaller difference, but it does get worse and worse with higher uric acid. So for elevated cholesterol, not having elevated cholesterol, lower were definitely better. Under 2, under 3 were clearly the best you could get. And for kidney disease, goes without saying. So except for truly hypouricemic subjects, less than 3 in men and less than 2, that's too low. So if it's lower than 3 in men, that's too low. Lower than 2 in women, that's too low. Lower serum uric acid levels, is an independent protective factor for cardiometabolic diseases for these 4 conditions. So uric acid and cognitive decline as an example of a double-edged sword of uric acid. So low serum uric acid is associated with, so too low, those hyperuricemic patients or clients, whatever, those numbers are associated with Parkinson's disease, multiple sclerosis, and Alzheimer's. High serum uric acid levels increase the risk of vascular dementia. Vascular dementia is blood flow to the brain, obviously heart disease, what we just talked about, and increased cerebrovascular decline. The relationship between serum uric acid levels and neurological disorders may be U-shaped. That's from 2018. I told you, very recent. Uric acid and cognitive decline. Here's what that looks like. Low, Parkinson's disease, ALS, multiple sclerosis. High, dementia, Alzheimer's, cardiometabolic diseases, gout. Pretty straightforward. So what is the ideal? The ideal is for men under 5, for women between 2 and 4. Remember those numbers. This made me change my recommended optimal range for uric acid. And over the, now nearly 25 years of taking labs on people, I was probably not really brought into thinking about uric acid in a new way up until about 5 years ago, until we got into keto and started challenging a lot of concepts. And this concept of what is the optimal range for uric acid is only a couple to 3 years old, 2 to 3 years old. So it's very new, very cutting edge, and I hope you take this seriously because it's a big deal, as I will show you. Had to change the optimal range of uric acid. From this, I used to call it, my optimal range was better than the conventional, was 5.5 was the sweet spot. That's not off by much, but now I differentiate it into men and women, slightly different. But the conventional range was 3.8 to 8.4, call it 4 to 8.5, way too high for a normal. And so now we've changed it, women 2 to 4, men 3 to 5. Conventional is still 3.8 to 8.4. So this is where you come in. If you're getting your data only from your doctor's annual visit, you need to look at your data and say, that's too high. You need to overrule your doctor because you now know more and saying, and there's a study you can go to show it to them. Okay? There you go. It's helping me, so it's going to help you. So this is how we should see it now. Optimal range is women 2 to 4, men less than 5. Beyond that, hyperuricemia, which is getting out of control for all those other conditions, right? And hypouricemia was the Parkinson's neurological, Parkinson's, ALS, and multiple sclerosis. But what you haven't been told about uric acid is what has changed globally over the last 70 years, and the incidence of gout has nearly quadrupled over the last 40 or 70 years. Do you believe me? Okay, here we go. Proof. Just 4 different studies. I grabbed them, threw them together. Proof of global incidence, a global increase of gout. This is from 1997 to 2012. So that's 15 years. This is the same 15-year period from 97 to 2012. That is the UK. This is Canada, rising incidence of prevalence of gout in the Canadian general population. British Columbia has a nice study on it too. It's too much to fit in. Epidemiology and prevalence of gout in mainland China. And that was from 1995 to call it 2020. So that's 25 years. Look at that. Look at that. From 0.5 for males to coming up to 4. That's more than quadrupled. And here you have, in Hong Kong, you can say, well, it's like China. Well, it is and it isn't, depending who you're talking to. But what I want to differentiate is crude incidence of measuring versus age-adjusted. Look on the more refined, age-adjusted in the course of 2006 to 16. So we're looking at just 10 years. This is 25 years. This is just 10 years. And in 10 years, from 2006 to 2016, it has gone up by 50%. Crude has gone up by 100%. So it is going up. You can pick your country. Could have done Taiwan, could have done New Zealand, could have done Australia. And so they say, I've never been a sugar guy or gal. I've never had these other things that have been discussed. What's going on? That's what I want to tell you about, because you have to look at the bigger picture, which is not that complicated, but you need to look at something that's a little more comprehensive. You need to be a little more savvy. Excuse the jets going by. You need to be a little more savvy about yourself. You need to know your own data. So don't just go, I'm going to take these things in case I have elevated uric acid. No, find out where you are. That's what I talk about. You got to track, and if you have an issue, then track what you're eating. That's the first place I would go. But it's not just about what you're eating, as we'll get to later. Okay, so here's the context that I want to set for you to think about. Since gout, and we're using gout, the reason we keep on coming back to gout when we talk about elevated uric acid is because gout hurts, and people who hurt go see their doctor, and it's discovered they have elevated uric acid. Of course, people who aren't hurting or in pain don't necessarily see their doctor or don't go very frequently, and so they don't know if they have elevated uric acid. So that's what they call asymptomatic elevated uric acid, asymptomatic hyperuricemia. Those that are in pain and going, my foot, really hurts, or my knee, but usually it's about your foot. well, then they check it out and they go, well, here we go. I have a correlation. Foot hurts, elevated uric acid, you have gout. And if they really want to go further, they can find the kind of crystal you have to confirm it. And that would be through aspiration, which is not exactly fun. But so that's how that goes. We're using gout as a proxy because those are the people that go see their doctor or they go to the walk-in or they go to wherever. But we know this, over the last 50 to 70 years, and I'll even say 40 years, the rate, the incidence of gout has quadrupled. So back before 70 years ago, and back since humans became Homo sapiens and sort of broke away from the family of great apes, that was always about the same level. There wasn't this, the first incidence of gout I've talked about before was nearly 5,000 years ago, 4,260, whatever, in Egypt. Okay, and then it goes on. We know a lot of famous people that have gout. Benjamin Franklin, various actors, Laurence Olivier, Thomas Jefferson, and so on and so forth. But what are the other factors? Yes, it's alcohol. Yes, it's what they call it's sugar generally. So when we say high fructose corn syrup, we say high fructose. It's not that it's fructose by itself that you do get from fruit, clearly. It's the fact that you have high fructose corn syrup back in the 70s when it finally became available, drove the cost of sugar down so cheaply, suddenly it's soft drinks were so cheap and everybody started having soft drinks and very sugary food. That's what happened. So when we cite high fructose corn syrup, it was an event that drove the price of sugar down. And high fructose corn syrup is marginally higher. Sugar, sucrose, is glucose, and fructose, high fructose corn syrup, is just a smidgen over 54%. So it's about the same. So it's not about fructose per se and by itself, and I did a whole video on that, and you can see that above. It's about sugar. Glucose and fructose together are sucrose. That's what that's about. So that was a big driver in the 60s. But what else increased in that period of time? The amount of omega-6 in all of our foods that we have, and that's called in carbohydrates, and in the meats that we have, unless you live on some farm and you know that it was grass-fed, whatever it is you're eating. So all of those grain-fed animals that you are eating, be them poultry, be them pigs, be them beef, be it whatever it is that you're eating, lamb, they suddenly have a much higher level of omega-6. That muffin you're having post-1970 is far higher. All the oils, the soy oils, the vegetable oils, that's what they use. So it's no longer lard and other oils that they use. Dramatic change. So omega-6 spiked up, both in the meats and the foods that we eat. And certainly how we cook it is vegetable oils. I wanted to provide a little more detail about some of these other factors that are increasing uric acid, your uric acid, but it's been happening over the last 70 years. It's important to know that. It's important to know, as I say, the honest data so you can apply it to your situation. It's not going to be confusing, I guarantee that. So first you must ask two questions, right? What has increased over the last 7 years and what has decreased over the last 70 years since World War II that we can show has directly contributed to the increasing uric acid levels and raising incidence of gout, dementia, Alzheimer's, cardiometabolic diseases, etc., diabetes, obesity, throw it in there. So, answer right off the bat, the biggest things that have increased over the last 70 years that affect uric acid, and this is in addition to the high fructose corn syrup. We'll touch on that a little bit today, but I've already covered that in this video above called the fructose myth, exposing the fructose myth. So, we're talking about omega-6, we're talking about antibiotics in our food and personal use, alcohol sugars, xylitol, mannitol, sorbitol in our food, low-dose aspirin, which was an unsubstantiated medical recommendation that many follow. Okay, omega-6. Our consumption of omega-6 over the last, since the 70s, over the last 70 years since World War II has been enormous. So cooking vegetable oil, so you have the corn oil, the soy oil, the cottonseed oil, you name it. So the vegetable oils contain toxic chemicals linked to cancer and brain generation by scientists. That came out in 2015 from the UK publication called The Independence. Oils made of sunflower seeds, soy, beans, corn oil are worse for health than butter, lard, and olive oil, research has shown. And there's the link for that should you want to jump in and read that. It's pretty cool. So processed foods, we all know what processed foods look like. Know that not only are you getting omega-6, but you are getting high fructose corn syrup in most of this as well. Okay, over here, grain-fed meat, pork, farm-raised fish. The ratio of omega-6 to omega-3 fatty acids was over 16 for the grain-fed tallow, which is beef fat, but only 1.4 for the grass-fed. That's huge. 16 to 1.4, that's really roughly about a 12 to 1 ratio difference. Considering it used to be 1 to 1, it's not perfect. To be clear, that's an omega-6 to omega-3 ratio of 16 to 1. Grain-fed versus a 1.4, which is a smidgen over 1 to 1 pasture-fed. So we're talking about eating the grass versus eating the grain, right? Eating the grass, going out in the pastures and just munching on the grass and not the grains, or staying in the barn and being fed grains of the corn, of the soy, of the et cetera, et cetera. So, and that's from 2022, that's this year, nutritional benefits from fatty acids in organic and grass-fed beef. Great article. This is Dr. Sinopoulos, who I totally think is a wonderful researcher, and his life work is really made a change in my life, and I'm hoping yours as well. So here's we're having a hypothetical big picture look at the change, right? Nobody can go back 10,000 years, but we can speculate given the DNA and all the archaeological and anthropological evidence we have. I'm going to get to vitamin C in a future video, so I'm going to skip through that. We have vitamin C, E has declined, saturated fats have increased, omega-6 has increased, trans fats, a whole nother issue, which is about processing, of course, and omega-3 has decreased. Since the 1950s, and that's this line right here, that's the beginning of the obesity epidemic. Okay, the oils we used in our foods have changed. Again, notice the dates. These are the 2 nutritional studies were done in the United States and supported in Australia as well. And I've talked about it future past videos up here on omega-6 and the deceitful research on that was exposed by Dr. Ramsden. Okay, so what we see is soybean oil has just taken off. And corn, what do we have? Cotton, what are the other ones? We have cottonseed oil, but primarily on this particular diagram, it's soybean oil. This is where vegetable oils are taken off. And the studies here were trying to prove that polyunsaturated fatty acids, meaning soy or vegetable oils, were a lot better than saturated fats. Here is actual tissue comparison. So linoleic acid, which is another word for omega-6, it's one of the 2 main omega-6 fats in the US body fat, 1961 to 2008. So that's what, 50 years? There you go, 60 to 2010, more or less. Direct line comparison, the amount of omega-6 fatty acids in the body has increased by more than 200%, 3-fold in the past 50 years. Holy cow! Holy cow. All right, a comparison chart, omega-6 to omega-3. And this is current about food you're actually eating and in a context of time as well. Okay, Paleolithic, we're saying it was under 1 to 1. What did they have Paleolithic? They basically had lean game meats was their diet primarily. And there's the name of the diet there, and you can punch that in and look that up. Greece prior to 1960, this is by Artemis Sinopoulos in 1999. And this is basically saying the information that was left off in the 7-country study by Ansel Keys, who she knew directly and worked with, from my understanding. The current United States is 16 to 1. I would say 16 to 1 of omega-3 ratio is incorrect. It's higher than that, and I'll show you on some of the labs. United Kingdom and Northern Europe is 15. Japan is really the healthiest today, and that's a 4 to 1. That's pretty good. Rural India, 5 to 6 to 1. Urban India is up to 50 to 1. Can you imagine all the diseases? So the data is from this particular study, intake of long-chain polyunsaturated fatty acids during the Paleolithic and world time. Okay, so these are my labs now. I just pulled out like I usually do. Is this about 20 patients or 15 patients? It can go on and on and on. The problem about getting too much data in there is you wouldn't see what I was talking about. What I want you to notice is the highest omega-6, which I'll point out because we have that, the omega-6-3 ratio, has the highest inflammation, the highest mitochondrial dysfunction. So here we have, I've made it pretty straightforward. These have, here's your omega-6 to omega-3 ratio, 17. There's one about 6. So not all of them are that way. So 17, we'll call that 18 over 17. Here's a little over 14, and I could have chosen others. So let's look at here's inflammatory marker, 4. You want, it has to be under 1. There's 4. Here's 4.5, has to be under 1. Here's 3.5, has to be under 1. So when you look at the comparison, it's a pretty tight correlation. Also, if you want to look at insulin resistance, that's here. Insulin resistance, you want under 1.5 for this HOMA-IR, a lot of data. So insulin resistance, and it goes on. You can look at other things we'll get into later. I'll come back to these. Okay, the reality of this dramatic change is on our dinner plate every night. Should you eat some of these foods? Like I do. Grass-fed beef, I already told you about that. The ratio is here it says 1.54. We said what, 1.4 before? Pretty darn close, don't you think? Whereas grain-fed, right? They're being fed grains, they're not eating the grasses on the hillside and so on and so forth. It's a 5-to-1 ratio. Still, you can say that's not so bad. Nope, not so bad. What we saw in the other study was said it was about a 16-to-1, so that is substantial. So now we get into chicken breast, 16-to-1. This is the factory farming chicken, right? Chicken thighs, even higher, 17. Pork chops, nearly 30. Why chicken and why pork chops? Those are the most factory farmed animals. They really got it down to masses of chickens, masses of pigs, being farmed together. It's not quite that way yet for beef. Some can argue, because beef are outside, and they are, as much as they're crowded, far crowded than they were before. If you want to go back to the roots of understanding that, a great book is The Omnivore Dilemma, and it kind of covers that from about 15, 20 years ago, so it's not a new issue. You must have an omega-3 of 8%. That's the omega-3 of 8. You want 8% to avoid heart disease. Preformed sources of EPA, that's an omega-3, DHA, are required for this. So you get preformed when you either take supplements, of course, but better is when you eat omega-3 fatty fish, cold, Arctic, charred fish that are high in omega-3s. It's there. The body doesn't need to work on it. It is taken in and it's immediately useful. Whereas if you use plant-based, which we call omega-6 and omega-3 as ALA, that has to be broken down and converted into EPA. So it's a whole process there of taking ALA to EPA. Anyway, so when you eat fish, fatty fish, not farmed raised, wild caught, as much as it exists in the world and for you to have, is already, your body uses it immediately. No breaking it down, just takes it in. For the human diet to reach the level in the blood of EPA and DHA, ALA is poorly converted to DHA. 2 studies, omega-6 pathway, omega-3 pathway. This is saying preformed. This is what you get from fish. That's what you get from fish. There's no conversion. There's no eat it, digest it, bring it in. If you're saying, well, I'm going to get my omega-3 from veggies because I'm going to eat high veggies omega-3, all right, I'll say, okay, you can do that. Go find your omega-3. But problem is, not everybody can convert it, and most people cannot convert ALA to EPA and then to DHA very well at all. And that's another story waiting to be told down the road on these particular genetic mutations. This is from a trip of mine from the Yellowstone saying, so what do beef, what is the real world, what do the wild game eat? They graze. They don't eat the grains, they eat the grass. What does high omega-6 to 3 ratio have to do with uric acid? Okay then, so when we talk about excreting uric acid, remember I said a third goes through the gut. If I said that, I've said it in a number of videos before, we're going to get to that coming up. A third goes through the gut, 2/3 goes through the kidney, to the liver to the kidney. All right, of that, it gets excreted out, but then it gets reabsorbed, right? It gets put out to the urine, it gets reabsorbed. And so that's how your kidneys work, is fine-tuning the excretion, reabsorption, excretion, reabsorption. So I want you to know that because omega-3 polyunsaturated fatty acids inhibit the function of reabsorption. They call it the urate-1 receptor. You really don't need to know that. Just know that once it's excreted, it keeps it out there. You're not coming back in, baby. You're out. Just get out of here. Here's another more technical way of looking at that. All the blue ones, all the blue saturated fatty acids, makes my heart to say this, does not block the intake, the reabsorption of uric acid. Whereas there's the omega-3, EPA, is the highest preventer, right? Is the highest blocker of reabsorption. So the idea of activating urate-1, if you really want to get technical, it blocks the reabsorption, therefore more is sent out. The throwing away, the waste, the excretion as an out of the body, higher with omega-3. And so let's look up here with omega-6. Omega-6 does not block your uric acid at all. The omega-3 polyunsaturated fatty acids, all these 3 are omega-3s, are the greatest blockers. So that's a natural block. It's unfortunate we talk about it that way. It's just how omega-3. So here we go. Omega-3s decrease uric acid by inhibiting reabsorption. Omega-6 which is in our foods, what we've just been through, increase uric acid by reabsorbing it. And you can go through line by line. That's the takeaway I want you to, this is how it starts up linoleic acid, and you can go down step by step, but I want to make the big points. Don't lose the big points for trying to get the details here. Okay, let's take a global survey of who is highest, as much as we know that, in eating those fish. Well, that makes sense the farther north they are, because the fattier fish like the salmon and the Arctic chard, and this is where the world's #1 export of Arctic chard is in Norway. So we have global survey of the omega-3 fatty acid DHA and EPA in the bloodstream of healthy adults. What we have is Norway is the only Western country that is high or appropriate, has the appropriate levels. So that's to say above 8%. And arguably you could say Greenland, which is actually where the first studies were done back in the 40s and 50s on omega-3s. But after that, it's all downhill. Great study. Look, I hope you looked that up and look at that. Okay, the second thing that increased is antibiotics. Post-World War II, which is about 70 years ago, antibiotics came in as this wonder drug. Absolutely huge wonder drug. And it transformed people's lives, and it still does. But we have other issues for that right now. So antibiotics have been first used as the miracle drug in the 60s, all the way on up. Now we have the antibiotic resistance, of course, and we're supposed to be using less. But that's on humans. Did you know that starting in the 50s, and that 80% of the consumption of antibiotics in the United States is for animals, large care animals, horses, cows, cattle. What they learned is not because they're sick. What they learned is by giving them antibiotics, the animals get bigger and heavier and fatter. And if you are paid for a cow by pound, you want it to be bigger and heavier and fatter. That's what happens. So they would give, this is well documented from the 50s to certainly up to 2010. And now supposedly they've backed off a little bit. But that's the other source of antibiotics that you are getting. So not only are you getting high omega-6, you're getting antibiotics, which is certainly adding to the antibiotic resistance. And that's not where I'm going with this. But what does this have to do with uric acid? A third of your uric acid is excreted, gotten rid of, through your intestine. When you start taking antibiotic, it alters, if not kills off, a portion of your microbiome, the bacteria that are specific, and there's a lot of other things. Long story short, it reduces the intestine's ability to excrete uric acid, antibiotics. So what about omega-6? What does that do? That's a very pro-inflammatory. So that guy or woman, mostly it's a guy who came in with his gout, limping in, unable to put his weight on his foot suddenly, that pain was probably 10 times more inflamed than it had to be because his omega-6 to 3 ratio is probably anywhere from 15 to 25 or more to omega-3. And back before 1960 in Crete, by the way, you ought to look up Dr. Artemis Sinopoulos. She's the one who has spent 60 years focusing on the omega-6-3 ratio and how out of kilter that is. But anyways, in Crete, for example, in 1960, the ratio of omega-6 to omega-3 was 1:1. That's a very non-inflammatory metabolism to have. Incredible. So when you're 25:1 omega-6 to 3, it's like dry kindling waiting for a spark and causing systemic inflammation. So why and how everyone is on antibiotics? You don't believe that? I'm going to prove it to you. Unless you live in a very special part of Alaska or someplace in the Northwest and you really have your own sources of food supply, I'm going to show you how all of us have been on antibiotics for the last 70 years if you're that old. Okay, the consumption of antibiotics through the food we eat and as medication can compromise our gut to eliminate uric acid. 1/3 of our uric acid is eliminated through our gut. So anything that affects our gut is going to affect our ability to excrete, to get rid of uric acid. So the question then becomes, does the antibiotic in our food, meat, poultry, and fish, affect our gut's ability to eliminate uric acid? Do the antibiotics we take personally affect our gut's ability to eliminate uric acid? And I'm going to give you some information to make you think that absolutely. All right, so tetracyclines and Macanolides create collateral damage by wiping out good bacteria, and this is from a study, in the gut. Tetracyclines are a type of broad-spectrum antibiotics. Macrolides, 5 types: erythromycin, clarithromycin, azithromycin, or the Z-Pack, as a lot of people know, fidaxomycin, and telithromycin. They're used to treat a variety of common infections, from acne to sexual transmitted infections, STDs. Researchers have found that tetracyclines, macrolides, not only stopped good bacteria from growing, but they lead to the death of about half of the strains of microbes. That's all the bacteria and the viruses and everything else, mostly the bacteria we're talking about, found in the gut the researchers tested for. Unraveling the collateral damage of antibiotics on the gut bacteria, and that's from 2021. That just came out, and that was in Nature. Hope you read that. So antibiotics and increase growth in cattle. Farmers began giving drugs to their livestock, for example, to treat milk cows' infected udder, and noticed that animals who got antibiotics grew larger and more quickly. This led to a flood of patent applications for antibiotic-laden foods for all sorts of livestock. The drug company Merck filed a patent for a method of accelerating the growth of animals with a novel growth promoting factor that was primarily penicillin. I don't know about you, but in my childhood in the 60s and 70s, we were a family of swimmers, and we all got ear infections from swimming, Staph aureus. My dad, who was a doctor, gave us penicillin, so we had plenty of penicillin. His father actually died because he didn't get penicillin during World War II, and that's a whole other story. So he was pretty much pro-penicillin in our childhoods. Eli Lilly patented 3 new antibiotics to mix into the feed of sheep, goats, and cattle because the microbe-killing agents increased feed efficiency. So that's a term, feed efficiency. And that means turning calories into weight on the hoof. In the ensuing decades, it became a standard practice to give livestock copious doses of antibiotics to make them grow faster and larger, not to treat diseases, not to make them healthier, but simply to pack on the pounds, even though no one knew why this happened or what other effects the practice might have. Doctors in Newport, Rhode Island had to change one of their policies last year being, I guess, 2018, 2019, because they inadvertently made a young woman obese. So we went from cattle and livestock to a person. They made somebody obese by giving them antibiotics. The fundamental link between body weight and the immune system, 2019 article in The Atlantic, and that's a great article. Taking antibiotics early in life leaves mice prone to obesity. Now there's a picture for you. But this is from a big study, more than just mice. It's extrapolating the effects that we see on mice. So children born by cesarean section, as well as those who receive antibiotics during their first year of life, have a higher risk of developing immune disorders such as asthma, type 1 diabetes, and have an elevated risk for obesity. Pretty straightforward, right? A lot of work on obesity has been focused on diet and calories, and that has not been sufficient to explain the obesity epidemic. Antibiotics could be the missing piece of the puzzle. This is by Dr. Blazier. He's probably the foremost knowledgeable person on microbiomes in the world. He's worked with the Hadza, the hunter-gatherers in Africa. I think it's Tanzania. He's worked with and done bowel studies on Amazon, deep into the Amazon. So he's had such a global understanding of microbiome. Put it politely, he really knows his shit. Okay, so taking antibiotics early in life leaves mice prone to obesity. Disrupting the developing gut microbiome may affect metabolism, 2014. Animals in the US consume more than twice as many medically important antibiotics as humans. 70 for humans, 70 for animals, 30% for humans. Are you getting the picture? Most probable antibiotics that cause uric acid increase: amoxicillin and erythromycin. And you can look those up individually, by the way. That's where we got the information. Antibiotic use in agriculture varies greatly by country. Just glance at this. The worst is Cyprus, the best is Norway. Norway, Scandinavia, I guess you could say. I don't know about Sweden. Where's Sweden? But anyway, Norway, Iceland, which is not Scandinavia, Nordic, but not Scandinavia. Sweden's, yeah, so there you go. And New Zealand, very low. United States is down here. So United States, Germany, and Portugal are pretty much all the same. And then Hungary is worse, Italy is worse, Spain is worse, and Cyprus is the worst of all. And that was from a report in 2015. Do you think that improved? So what does this have to do with uric acid? So here is, again, from Martin Brazier, Dr. Martin Brazier, 2016, antibiotic use and its consequences for the normal microbiome. And what he showed was after World War II, this is microbiome diversity scale. So the diversity of our microbiome, and he definitely knows what he's talking about, worldwide, decreased dramatically. Do you think that put us at risk for a few things? Perhaps. All compromising our ability to get rid of our uric acid. What he has, these different lines, this is World War II, and this is country with late modernization. So when you think about countries that really were not visited much until World War II, so that would be Oceania. Think of the Pacific War. So consequently, we showed up, gave them our stuff, done. And what is this last line? This is probably inner Amazon and very remote areas now that are still starting to make a change. Antibiotics, omega-6, they increased a lot. If you want to add the high fructose corn syrup to that and insulin resistance, the whole thing is just building up. But what I'm trying to say, it's not just high fructose corn syrup. It's not just, there you go, that's the reason. If you are eating the standard American diet, then don't do that if you care about your health. You move on. Most people that are watching this video are not eating the standard American diet. They're already aware enough to move away from that. Maybe they've moved away from it completely. So we're talking about, ideally, when people talk about back to meats, why would you pay the extra money to be grass-fed as opposed to grain-fed? Well, the difference there is, and forget about the snobbiness of, oh, it tastes better and all that other stuff, fine, good for you. No, the difference is in health. And the health is they have a 1-to-1 ratio of omega-6 to omega-3. You're eating appropriate meat. You're eating evolutionarily appropriate meat that's gone back hundreds of thousands of years since we became Homo sapiens. So before 70 years ago and going back before that, it was 1-to-1. Now we're eating things that are so out of kilter that it immediately. So why am I talking like this? I'm trying to justify how we got to a quadruple rate increase of uric acid, of elevated uric acid, and all the problems that causes. All the problems that causes, as covered in previous videos, it covers dementia, Alzheimer's, heart disease, vascular, cerebrovascular, which is basically brain issues, and vascular dementia as well. Those are big issues. Those were just 3. Okay then, before we go on to the next question, which is what are the deficiencies that existed in most of us, do exist now in most of us, that have directly contributed to increasing uric acid rates, directly contributed to the incidence, the prevalence of gout in all these countries, in our own country, United States. That's worth going into, and it's a fun topic to go into. But before we get there, I need to go into one more topic in terms of what is present in our diet that was not present in our diet 70 years ago that directly contributes to increasing uric acid levels. Stay tuned. We'll knock that off and we'll get back on track. Bye-bye. So if this is something that you're interested in, that is a topic that I obviously go deeper in terms of labs, in terms of how to do it, in terms of why you would want to do it, various topics, as you've seen that I've done in the past, then please let me know below in a comment. Till then.